All right, let's try to do number 12. We have two premises, a disjunction and a conditional. We're trying to get a conditional. So that means it would maybe be a good strategy to use conditional proof. What that would look like is we would assume W, and then somehow we're going to try to get X, and then by the rules of conditional proof, we could write if W then X. First line, arrow, last line. So let's try to do that. So we assume W in a pretend world. We don't know if W is the case, but let's assume it and see what it gets us. Assume for CP. Now we're going to try to get X at some point. How can we get X? X, we have not X right there, and we have X right there. So maybe we can get X in 2 somehow. Well, if W then X, we already have W, so we can put on our wish list if W then X, which strangely is actually the ultimate thing we're trying to prove. How can we get if W then X? Well, if we had this left side of this arrow, we can do modus ponens to get this. So we'll put that on our wish list. If X, then O. How can we get if X, then O? Well, this says not X or O and W. So if we had X, we know that the left side of the disjunct does not hold, but the right side does. So that basically tells us, but we gotta, that if X then W, then O, but we gotta get there. If you look through your rules, you might recognize that we have a disjunct, and then on one side of the disjunction we have an and that should remind us of a rule of distribution. That's like this version right here, P or Q and R. That's like the P, that's like the Q, and that's like the R. And that tells us we can get something like that. So let's go ahead and use distribution on line 1. Line 1, distribution. And that's going to give us not X or O and not X or W. Awesome. We're still trying to get X, and we thought we could get there through this path if we have if X then O. Well, the left side of this conjunction might be useful. Since this is a conjunction, we can just pull out this part by simplification. So for simplification gives us not X or O. Now to get if X then O, hopefully this reminds you of the rule of material implication. So what's equivalent to 5 would be if X then O. And now, as we reasoned backwards, now let's reason forwards. So from if X then O, we could get if W then X. And how did we get that? That was from line 2 and line 6, modus ponens. Line 6 is the affirmation of the antecedent, which means we include can conclude if W then X. Now, we're still trying to get X at the bottom. We have if W then X. We also have line 3. We have W by itself. So line 7 and line 3 together with modus ponens is going to give us X. So now we can close our box, close our imaginary world that was all based on the assumption of W being the case. And we've shown that by assuming W, that will get us X. So if W, then X. And that's 3 through 8 conditional proof. We got our conclusion. Awesome.